Suppose that the heartbeat per minute, BPM, for a group of male adults has a normal distribution with a mean of 66.1 BPM and a standard deviation of 10.8 BPM. Instead of using 0.05 for identifying significant values, use the criteria that a value x is significantly high if the probability of x or greater is less than or equal to 0.01, and a value is significantly low if the probability of x or less is less than or equal to 0.01. Find the pulse rates for males that separate significant pulse rates from those that are not significant. And then using this criteria, is a male pulse rate of 95.5 beats per minute significantly high? So the first thing we want to do is to help visualize the area of interest. We want to sketch the normal curve, labeling the mean and the approximate position of any specific x values, and shade and label the region or regions representing the probabilities that are significantly low or significantly high. And next, recall that we are shading the bottom 0.01 of the data, which is below 1%, and we are shading the top 0.01 of the data, which is above 1%. So let's go ahead and draw our bell curve. So there's our bell curve, and what we do know is the mean, which is 66.1. Okay, and we also know that we're looking for the areas on the left and the shaded areas to the right. And so this is going to represent 0.01, and this area also represents 0.01. And so what we're looking for is, or what we want to find is, what is the x value that's associated with those two areas. So what we're looking for is x1, and we're looking for x2. Okay, so underneath that, we're going to take a look at the z-scale. Now the z-scale tells us that we have a mean of 0. So we want to find the z-score that's associated with the bottom 1%, which is the 0.01 to the left of that. And then we also want to find the second z-score, which has the area to the right, which is 0.01. So we want to find the z-score that corresponds to the bottom 0.01 and the top 0.01, rounding to 2 decimal places. So we're going to let z1 be the z-score for the bottom 0.01, and we're going to let z2 be the z-score for the top 0.01. So let's go ahead and use StatCrunch. So we're going to open up StatCrunch. We're going to go to Stat, Calculators, and select Normal. Make sure that our mean is 0, our standard deviation is 1, and we want to make sure that this is less than or equal to, and we're going to put in the area of 0.01, and then we're going to select Compute. So we're going to go ahead and do that. And if you notice, what we get for our z-score for the one on the left is negative 2.33 if we round that to 2 decimal places. So we get negative 2.33. Okay, now we want to be able to find the z-score on the right, which has the area to the right, which is 0.01. So the best thing to do here is to come up to Options and select Refresh. And now we're going to change this to be greater than or equal to. And then we're going to put in the area of 0.01 and then select Compute, because then you can see that the area is shaded to the right. So if you take a look at the z-score, what that gives us, rounded to 2 decimal places, is positive 2.33. So we get positive 2.33. So therefore you can see that we get Z1, which is equal to negative 2.33, and Z2, which is 2.33. Now, there's another way of doing this using StatCrunch. We can find the area that's in the middle. Well, the area in the middle is taking 1 and subtracting 0.01 minus 0.01. Okay, so 1 minus 0.01 minus 0.01 is equal to 0.98. So that's the area that's in the middle. So what we want to do was, we can use StatCrunch. We can come here and select between. And so what we can do is put in the area of 0.98 and find out what are those values that are in between. So you can see here that that also gives us those two values, negative 2.33 and 2.33. Now that we found the z-scores, what we want to do is we want to obtain the corresponding x value, we want to then substitute the mean to be 66.1, Z1 to be negative 2.33, and the standard deviation to be 10.8, and then we're going to plug it into the following formula. So when we plug in the following formula, we have the mean to be 66.1, the z-score to be negative 2.33, and we have the standard deviation to be 10.8. So we have to follow the order of operations, negative 2.33 times 10.8. Multiply those together and then add 66.1 gives us 40.936. And then rounding this to one decimal place, we get 41.0. So therefore, we would say the lower pulse rate separating significant values from those that are not significant is 41.0 beats per minute. Now to obtain the corresponding x value, the next x value, which is x2, we're going to use the same mean, which is 66.1, same standard deviation of 10.8, but z2 is positive 2.33. So we're going to go ahead and plug those values in. So the mean again is 66.1. We have our z2 score, which is positive 2.33, standard deviation to be 10.8. So if we take 10.8, multiply it by 2.33, and then add 66.1, we get 91.264. Rounding it to one decimal place gives us 91.3. Thus, the upper pulse rate separating significant values from those that are not significant is 91.3 beats per minute, rounding it to one decimal place. Now, to determine if a heart rate of 95.5 beats per minute is significantly high, compare this value to the significant upper pulse rate of 91.3 beats per minute. If it is greater than a significant upper pulse rate, it is significantly high. If it is less than a significantly upper pulse rate, it is not significantly high. Well, in this case here, because 95.5 is above 91.3, we would say that it is significantly high. And let's just put our two x scores back up into our graph so that we can see what the graph looks like. So x1 is 41.0. So if we come back up here, we know that x1 is 41.0. And then we found the other value to be 91.3. So therefore there's 91.3. And you can see, comparable to the mean, which is 66.1, the value over here is less than that number, and the value over here to the right is greater than that number. And therefore anything beyond that would be significantly high. So if that 95.5 would then be significantly high.